the first two were just asking you to identify if they're independent versus dependent. If they're the same group of participants use both times with the before and an after, they're dependent. And that's used a lot, like if they're trying new medicines, they test before, they test after. Heartbeats, heart things, a lot of that testing you'll see. Weight programs, they'll do that. So those are dependent. Right now we're only working with the independent samples on these guys. Our samples are independent. And sex, you comparing your males and your females, that's more of what we're doing with 8.1 and 8.2. Just to give you exposure. Number 9 was a good one. They gave you the results of the test. Now you have two things. The easy way, compare your p-val to your level of significance. Do a p-val test. A little bit more involved. You know that this is a two-tailed. Make a two-tailed. We know your level of significance, divide it by 2. Find your critical values for your cutoffs, and then test where your Z is coming. And you also get a reject H0. You can do it that way. P-val is by far a little easier. You're looking right at it. Anybody do this part of it? Yeah, it's a little more challenging. But it's
not easier than the p-val thing.
You like that better?
Yeah, it's visual.
It is a visual. It is. This is more of an abstract thing when you're looking at your p-val. And you're saying, what the heck am I testing? This by far makes more sense. I happen to like the rejection regions, but I'll flip to a p-val when it's easy. Okay, number 11, they just gave you the information. You're going to put it in your calculator. I like a table, whatever you would like to do. They gave you your claim, so it's two-tailed. Find your cutoff, inverse norm, don't forget to divide it by 2. Don't forget two-tails, share it. 2 sample z-test, get your p-val or get your z-score, and reject H0. Make sure you give me the decision. Your decision is either reject H0 or fail to reject H0. I need a decision. Your values are different? Did you divide by 2? You got 2.33?
No, I got 1.64.
1.64?
Wait, what? For what? What is the area?
You looked at 0.05, right?
What's the area? 645.
It's 0.1.
It's 0.01, isn't it?
No,
Oh, it's 0.1?
Yeah.
I had to go through there.
Oh, okay. That's why you got something different. So cut it in half, and it is your 1.645.
It's still
It's still rejected. Yeah. Yeah. Thank you. Sorry about that. I just switched around the numbers. Thank you. Is this one right? 0.10 on this one?
Yes.
Okay. Okie doke. The second one too, they gave you the claim. Your tail is to the right this time, and it's the level of significance of 0.10. Yes.
Do we have to make those charts?
Nope, because they gave you the information. You didn't have to make a chart. I find the chart to be helpful when it prints out. Somewhere it did print out here. But I find the chart to be helpful. This way, when we do this t-test, it's really helpful because it's one right after the other goes in. So, you know, however you like to do it, they already gave you your information. If it's a word problem, I would definitely pull it out into a chart. But this one was pretty right there, right in front of you. And they gave you population standard deviations. Okay, now here comes your word problems. And some of you got thrown off by your N. You had 24 Model A machines, you had 26 Model B machines. Those were your N's. N1 and N2. Okay? Make a little, just pull out your information somehow. There's your mean, your standard deviation for your population, and your N's, your cutoff value of 0.05, don't forget to divide it by 2. And this was your reject H0. Because your claim was your H0 and you rejected it, you have enough evidence to reject your claim at a level of significance of 0.05 that the Model A washing machines cost are the same as the Model B washing machine cost. Questions? We're good? Amazing. We're amazingly good. Okay. Number 19. Here's a little chart. Put your information in a chart. I don't know if they gave it to you in the chart. You're comparing ACT scores for males versus females. And they're saying that can you reject the claim? Your claim was last. Can you reject the claim that the male and the females have equal scores? There's your claim. They can put it last. So we want to test if they're equal. And we turned out we don't have enough information to reject the claim that they're equal. If we don't have enough information to reject it, are we agreeing with it?
Yes.
Yes, we're agreeing with it. We just can't say we agree, we disagree, we like it, we dislike it. It's good, it's not good. We have to use the same words. There's not enough evidence to reject it, that they were equal. And this is one of the good ones you use this for, comparing your results from two different groups. Male and female are always a good one to bounce off of. And within each group, it has its own standard deviation and n, so it kind of takes into account, like even things like heartbeats and things like that. I think a female heartbeat is faster than a male heartbeat on the average. So it takes that into account when you do its own standard deviation and the n and everything else. So it does kind of take that into account. And the last one, again, they're comparing the ACT scores from someone who took a college prep program and someone who didn't, who took a general program. They're saying that the college prep program was more than the regular program, and there's enough evidence to support that at this point. And that would make sense, right? If your college prep program probably does a little bit more to help you get through your college tests. So that kind of makes sense, right? Okay. Questions on any of these? No? Good. Very good. So, simple. It's on the back of your note page. The first thing you're coming through your flowchart is right here. Are both your population standard deviations known? If they are, that's what we just did. Yes? And your population is normal. It says you approximate a normal population, or it's at least 30 and is greater than or equal to 30. Then we use your z-test, and we use your 2 sample z-tests. Okay? Now, if we do not know the population standard deviations, we have to use your sample standard deviations. We want to still know, is this a normal distribution? Or is n greater than or equal to 30? If it's not a normal distribution, you're done. You can't go any further. If it is a normal distribution, and you know your sample standard deviations, you would do a t-test. But we have one more thing to ask. We want to know, are their variances equal? If their variances are equal, we're going to use a t-test with a certain formula, but we're not going to worry about that right now. But your degrees of freedom are going to say, well, if they're equal, I want you to pool your variances. I want you to add them together, and instead of n minus 1, because you added 2 n's, it's n plus n minus 2. So you're pooling, add this to your chart, you're pooling your n's together. You're adding them together, you're putting them in a big pool. So when my variances are equal, we're pooling. Pooling will say yes. Because my variances are equal, there's not a lot of difference here. I can add my n's together, and instead of n minus 1 for degrees of freedom, because I have two n's, I minus 2. If my variances are not equal, you're going to use this version of it, but we don't care about that. I care about this right here. You're going to take the smaller of the n minus 1s. You'll get two different n's. Say n1 is 10, n2 is 8. You're going to do 10 minus 1, 8 minus 1. Whichever one is smaller, you're going to use. So this has a little bit of a glitch in here. We first have to determine, can we use a t-test? This is my t-test. And then we have to decide, are we going to pool their n's together? If the variances are equal, we say, well, there's no difference, combine everything here. If the variances are different, we're going to take the smaller of the n minus 1s. Okay, this is important. Okay. The rest of this will pretty much work the same. You're using a t-test. Your population standard deviations are unknown. Your samples are randomly selected. They're independent. We don't do dependent testing. We do independent testing. And we know that they're normally distributed, or n is greater than or equal to 30, because then it automatically approximates a normal distribution. Good? Here's our test statistic. This is virtually 0 over here. And this is a messy looking formula for the standard deviations. It gets a little worse because now it's n minus 1. But we don't have to worry about that because we're going to use your calculator. And your calculator is 2 sample t-tests. Right under the 2 sample z-tests. So we're going to bypass this mess with the standard deviations. We're going to bypass that. The only thing we have to worry about is when your variances are equal, we're going to pool your n's. And instead of doing degrees of freedom, is n minus 1, because we add the n's together, subtract 1, we're technically subtracting 2. Only difference. This is where they're not equal, and so we take the smaller of the n minus 1s. Major difference. That's it. The rest will work the same. Your cutoffs, remember, will bring you back to using your t-score, your table 5, your t-distribution. Just kind of nice because it has the one-tailed, two-tailed right there. So we kind of have it a little easier there. The rest of it sets up exactly the same. State your claim. Determine that this is in fact a t-score, a t-test. Decide if your variances are equal. Get your critical values, table 5. Your reject regions. We're going to use your 2 sample t-test. And we do reject, we do the same thing. Because you're using your calculator, you will also get your p-vals. Remember, we can't take p-vals off your table 5. But because you use your calculator on this, it will give you a p-val test. So let's try one. You ready just to try one? You guys ready? Okay. Let's give this a try. The results of the state mathematics test for a random sample of students taught by 2 different teachers at the same school are shown in the table. Can you conclude that there is a difference in the mean test scores for the students? How do I write that claim, that there is a difference?
Equal?
Not equal to. Equal to would be there's no difference. Is a difference, they are not equal. Your HO, the complement, is they are. Now, you have TCs this time. We have a level of significance of 0.10. We're assuming our populations are normally distributed, and their variances, their standard deviations are not the same. Their variances are not equal. So we're not going to pool. When they're not equal, we're going to use your degrees of freedom a little differently. And you're going to see it in your table. Let's see what they tell you here. think they work out the formula. Just so that you look at this, I just want you to see the formula worked out. We're not going to use it, but I just want you to kind of see it all worked out, and this is why we don't use it. If you take a look at page 439, there's their whole formula in there. Are you seeing their formula? Wait, sorry, this is the wrong one. It looks even scarier than that. It's not as scary as that one, sorry. Wrong page. That's a proportion. Page 430. This one's scary enough. Okay. See their formula? We're going to bypass that. We are going to find our critical values though. So now since we are not pooling our ends, we take the smaller of the ends, which is this guy, and we do your n minus 1. This is now your degrees of freedom. We're going to bypass that whole mess. I'm going to do it on a calculator. All we need though is your cutoff values. So go to table 5. Find me a 2-tailed test, degrees of freedom, 7. Find me your cutoff, table 5. It's like 818, somewhere around there. 2-tailed test, degrees of freedom, 7. Yep, it is 818. The level of significance is 0.10. 1.895. The left one is the negative one. Now, the rest is easy. Go to your calculator. We're not doing your formulas. Go to your calculator. Okay? Stat, test, come down to 2 sample t-tests. Stat, test, 2 sample t-tests. This one, look how nice this is. Here is your information for 1. Here is your information for 2. It's like right in order. Well, no, you're going to enter your information. But before, remember your standard deviations were first, and then your x1, then your n1. Everything is grouped together just like your table is. So enter your data. Guys, hang in there. Let's just get this in. It's what? Make sure you use your n, not your degrees of freedom. Don't pack up yet. Okay, now, what's your tail? 2 tails. Now here, is it pool? No. Take the no word. And then come down here to calculate. Here's your T. Here's your P value.